Are you hearing me? I'm hearing the back. Okay. Um, the second bullet point is part of what got me into disciplinary issues. I worked as a geologist for the Securities and Exchange Commission for 21 years in Denver. Part of it was investigating frauds, and while I've been a consultant since '96, I still get involved in some fraud cases, and they're still going along. Um, but oops, wrong way. What I want to talk about, this presentation will have two parts. One is some fundamentals. Sharon told us that there are people that sort of have an understanding of what ethics are and so forth, some better than some. But a lot of it, none of us have philosophy degrees or geoscientists. And I remember taking an ethics course in college and reading a lot of ethics for Vulcans. So we're going to start with some fundamental basics of ethics and morals and where professional ethics fits. And then I've got some case histories that we can discuss. And hopefully what's going to happen is we're going to have lots of discussions on some of these. If we only get through two or three, that's fine because we've had good discussion. And maybe it's going to have to cut me off when we get to the end because I've got more slides than we need. Okay. Right. Okay, this is, what are ethics and what are morals? If you look them up in the dictionary, ethics are defined in terms of morals and morals are defined in terms of ethics. Okay. So these are my definitions to distinguish between the two. Morals are informal statements, things that we all learn sort of by osmosis one way or another. We learn them. Ethics are codified statements. And so those of our societies that have a statement on professional ethics, that it's written down. General morals and ethics apply to things that we do at all times with respect to all people. Doesn't matter what our profession is or whether we're practicing it, just general life. Whereas professional ethics apply to the members of a particular profession acting in their professional capacity. So I've got this sort of triangle. We've got common morality down at the bottom that is something that all cultures that we know about understand. Next up is law, which is to some extent codified ethical procedures. Some extent is simply, traffic regulations. We all have traffic police for good reasons. But they only apply to those jurisdictions that are covered by the law. Here we're the District of Columbia, we go home, it's another state, city, and so on. Religion, some of us belong to religious organizations, some of us don't. Each of them have ethical, moral principles that one is supposed to follow. 631 if you're a really devout Jew, understand. And then there's professional ethics that just apply to members of the profession. If you really want to get into fundamental ethics for people, not Vulcans, please get a hold of Bernard Gert's Common Morality, Deciding What to Do. Because he talks about basic, fundamental ethical principles and some other things I'll get into. If you like philosophy, morality, its nature, and justification is the full bore professional philosophy professor version of this. Gert is both a philosophy, now emeritus professor of philosophy, but also medical ethics. And a lot of sciences that deal with living subjects there are all sorts of protocols and things worrying about what you do with living subjects. It's nice to work with fossils that are dead and have been for a long time. So mostly we don't have to get into that, though some of the engineering, hydrology, and some of the other things start getting into how we interact with society. There are two fundamental kinds of things. There are the moral rules that apply to how we are supposed to act with respect to all people at all times, and they're just a few. Then there are all the moral ideals, and these are the things that, first of all, we can't do them for everybody. For example, feed the hungry. None of us have the individual resources to feed everybody that's hungry in our particular communities. We can work toward that. We applaud the people that do that, but I'm not so much into, say, feeding the hungry as housing the homeless or raising money for one or another medical problem. There are lots and lots of these ideals that are valid, that are important, and you don't get demerits for not doing all of them. You may get some recognition for doing whichever one it is that you choose to do. So those are strived for. The other thing about most of the moral rules is that they're do not. And there are people who like to say, well, that's not positive. Yes, but it's a lot simpler to say what you can't do than what you can. A rule that says you're not supposed to walk around in public naked gets to the heart of the issue. We all chose to wear whatever we wore today that sort of met the don't be naked rule. But color and tie or not tie, the skirt or slacks for the ladies, that was your decision. It's an amoral decision, really, once you get the basic plan. This is Gert's fundamental rules. He says they're informal because all societies we know about these, even though they're not written down, recognized by everyone. And these are he came up with 10 rules. He admits he comes out of, a Judeo-Christian Western Civ tradition. So we have do not kill or murder, depending on which version of the command, which translation you're reading, pain, disable, freedoms, do not deceive I have in bold. That's the one that, as scientists, is probably our principal ethical, moral principles, that we do not deceive people. Not that we do some of the other things, but in terms of our professional capacity, that's the one where we are likely to get in trouble. Keep your promises. Obey the law. What's interesting is Gert says it's not obeying the law for most societies includes theft, but there are some societies that are truly communist, and if everything belongs to everybody, then members of that society can't steal because there's no private property. So, anyway, I won't go into details of those, but the other thing Gert recognizes, and this is important, there are exceptions to the rules. The rules everybody's supposed to follow all the time, but there are exceptions. Do not kill. Okay, some primary examples: self-defense, military, police, capital punishment. Everybody, I think, probably agrees about self-defense. When we get over to capital punishment, we might have a debate. But that's not the point at the moment. It is, at least in many jurisdictions, a recognized exception. Do not injure. I can't pull out my pocket knife and cut one of you open, but we let surgeons do that because we expect that the benefits of temporary injury from surgery will be far outweighed by the resulting alleviation of some sort of further medical problem. Do not deceive. Well, there are exceptions. A knife-wielding thug asks you where the intended victim is. You're allowed to say, I don't know, even if you do, because you're preventing a greater harm. Here are Gert's rules for identifying recognizable exceptions. The rules. So first of all, we have to decide what moral rule or rules are involved, who is harmed by the violation, what harm is avoided, can everyone in the same class of people, remember, so we allow doctors who have appropriate medical training to do things that other people can't, and all of them are allowed to violate the rule the same way. Is there an emergency involved? That can change how we do some things. Was the violation intentional? You know, we go from first degree murder to various forms of manslaughter, depending on the intentionality of an event in which you caused somebody's death. And that's all about intentionality, all those. Was there coercion involved? Somebody has a gun to your head, you may do things that you wouldn't otherwise do. And are you willing to publicly acknowledge and accept the consequences of your violation? This is integrity. It is being willing to stand up and do what you think is right, and if it's wrong, suffer, you know, if it's against the law, for example, suffer the consequences. Gandhi and Martin Luther King Jr., prime examples. Edward Snowden, not integrity. He has not said, I will accept the legal consequences in the United States. I'm going to go hide. So that's not integrity. Stephen King wrote a wonderful book on integrity if you want to read about integrity. He's a professor up at Yale. But get a hold of it. It's not the horror novels. But you know, he says integrity is like the weather. Everybody talks about it, but really nobody does much about it. But integrity is this business of publicly acknowledging what you're doing and suffering the consequences if there are. There are a lot of places where there are. Okay, here's an example. The insertion of standard, duplicate, and blank samples into a sample stream in order to demonstrate that your sample collection, preparation, and analytical processes are giving you the answers you think you're getting and that they're reliable and repeatable. So the rule of doing these, what are we violating? Well, we're violating the do not deceive because we're not labeling these as special samples. We're just sticking them in a sample stream. The harm done, increased analytical costs. You start on an mining exploration project, you should be doing this, some of these duplicates and some of these others every 20 samples. This is aside from the fact that the lab is doing this for its internal checks as well. These are checks you should be doing to verify that your analysis, you know, your number at the end means something. Harm avoided, the unknown reliability of the sampling analytical processes. Everybody should be doing it. And although the identity of these special samples, the standards, blanks, and duplicates, is disclosed, the fact that you're doing this as part of your quality assurance, quality control program can be very public. It's just that the lab doesn't know which sample is which. The other important thing is that ethical and moral consideration cannot resolve all questions. I've got 3 examples up there. Certainly since 9/11, we've seen a big shift in the balance between freedom and privacy versus the protection of the public health, safety, and welfare. Whether you think we can debate all these, the point is that these are issues that there is debate about, and regardless of which your opinion, you can have a very morally, ethically valid for your position, which is perhaps 180 degrees from our minds. That's okay. We need to respect each other's position and agree to disagree. There's not, strictly an ethical basis for concluding that one position is right and it's wrong. Okay, professional codes of conduct and so forth. So they generally apply only to members of that particular association. Should the same codes apply to everybody? To the extent that the codes adopted by a number of societies essentially track the language or the concepts, then you start saying, well, maybe this is a society-wide idea. But that's more push. Who sets the standards? Well, you get some committee together and looks at what other people have done and comes up with the guidelines. I was part of the committee back in '98 that came up with the AGI guidelines that were published in '99. And there were members of that committee who were horrified that there might be anything that suggested that there be discipline, because certainly there's society that don't believe that they need to have disciplinary procedures. I completely agree. I think most of us do not. But there's some that are doing certifying, licensing, those kinds of things are the organizations that need them. But the debate came up. We all agreed that honesty was the fundamental principle. I said, wait a minute. We agree with that. We've automatically said that dishonesty is therefore unethical. Get over it. Stop worrying about whether something's going to, the opposite's going to be something you can do something about. So it's some committee that reviews these things. Interestingly enough, the American Statistical Association explicitly has in its ethics code that anyone using statistics should be following their principles for the ethical use of statistics. They don't like the idea that there are lies, damn lies in statistics. That proper data analysis, well done, is very useful, but you need to think about it. So here is the example of somebody who explicitly has said we've got these standards applied to anybody using statistics, whether they're a member of our association or not. There are limits to our professional competence. And I have the examples of sexual harassment and discrimination here, ethnic discrimination. It's not that we don't think that violations of these are bad. I think we would all agree that they are. But we are not professionals in that field. We don't have the competence to go into the thorough judging of what's that. Some of us have had training in some of this. We see, a very flagrant situation or something like that. There are other people who have that competence to go and deal with the situation. Let the professionals, if you will, deal with it, and then we can say, okay, we have something in our code that says you're not supposed to violate laws or regulations. You've been found to have committed sexual harassment. That's something we decide we want to do something about. But we're letting somebody else who really knows about the subject deal with it, rather than trying to say that we as geoscientists are experts in it. So these are the general topics that topic headings that you find in the geoscience codes. Safety, advancement of knowledge, advancement of the profession, relations with colleagues, clients, and employees, and relations with students. This is what the topics from the AGI guidelines are from '99. So there's a lying, faking, deception, sort of the greatest scientific sins. A couple of examples: Piltdown Man, mining oil and gas rods. I got a whole talk about that. That's been published. Brex in '77, throw a little gold into your samples and create the world's largest gold deposit. Only took a couple ounces of gold. Faked production reports, overhyped property descriptions. I see this all the time. The fake data that led to the withdrawal of this water supply paper. It wasn't easy. I commend the survey for standing up and saying, hey, we found out this was a problem. Shred all copies or whatever it was that they said. The survey, went out, did public, and did the right thing. So when they found they had bad data out there, they said, there we go. That's integrity. They took the lumps and they got any lumps for it. Frankly, they deserved their applause. We had this problem with this fake bird ancestor from China back in 2000. I'll let the paleontologists go into details. Then there was this company called Intertech in Texas that was doing lots of air, water, and soil samples, environmental samples from all over the country. They were not doing the sorts of things the lab is supposed to do in terms of cleaning instruments before and after use, running check samples and so forth. Hundreds of thousands of samples that were called into question. There were a few people who were smart enough to be doing their own internal checks of duplicates, blanks, and standards, and caught these people coming up with bad results. The analytic was bad, and Intertech was criminally charged. So, just because the lab's got a good name doesn't mean that the lab is necessarily giving you good results. Although in the Briex case, the lab actually was correctly reporting the amount of gold in the samples they got. It's just that the samples they got had been salted. That's not the lab's fault. And there are other kinds of things that, for those of you in the mining business, everybody's excited about splitting core. Well, it works if the mineralization is homogeneously distributed through said core. Now, I got to tell you, in the cumulate setting of PGM deposits, the crystallization and mineralization is too heterogeneous. Even if you got a core like this, splitting it is not going to give you the same if you were to analyze each half. The core, there's not uniform distribution of the mineralization at even, if you will, outcrop or mine face samples. You got to do a lot more samples over a big area before you get statistical homogeneity. So a standard practice isn't. We'll get into more later. Okay, honesty, as I said, is the fundamental principle. Here we have 5 different quotes from AIPG's ethics code going to this point. The Friedis an article saying, scientists frequently do not acknowledge the limits of what they know and the uncertainties they involve. And this is a problem. And then we have Richard Feynman. Report everything, what you did and didn't work, what you're unsure about. So how many of you have read a paper that says we, or I, as a single author, tried this, tested this hypothesis, and it didn't work? I see 2, 3 sort of hands. I can remember one where this was done. That is something those of you in the publishing should say, we want to know what you did that didn't work so somebody else doesn't repeat it. That's useful knowledge, even if it didn't work. Just because, the results of your grant came up with a negative answer doesn't mean you shouldn't get funded again next year. You contributed something. And this bend over backwards of what do we know and what we don't know, this is really pushing the honesty issue. But it's not something that the scientific publishing world has really gotten its hands around and encouraged. Models. When I went to school, I thought we were ahead of the game. We had pictographs, like my great-grandfather, who had a quill pen and India ink to draw an absolutely gorgeous scale drawing of a locomotive and tender back in 1870s. I didn't have to adjust the width of the thing to get the. Now we have computers to do all these wonderful things real quick, and 3D models, and gee, they're wonderful. But geology is heterogeneous and nonlinear. We'll get in that in a minute. And I took a really interesting course at Mines on geologic data analysis. And one of the first examples was like for an F-test or something, was studying correlations between weathered and unweathered New Hampshire granites as to the uranium content. Well, mathematically, you can correlate, go from weathered back to unweathered. But that doesn't work geologically. Just because the math says you can do it doesn't mean that the answer is real. so, where the math conflicts with the fact of geology, throw out the math. You know, it's kind of like Kelvin, you know, looking at his heat flow and saying, well, that does the age of the Earth, but we did have a thing, well, if somebody comes up with a source of heat, because we don't qualitatively, it should be a lot more than 10,000 years. Models can never be validated. They can only be invalidated. And Naomi Oreskes had an interesting thought, which is, you're tweaking your model. Are you making it come out to fit the data, or are you genuinely tweaking the model in such a way that it does a better job of what it's supposed to be modeling? That's a hard with the more complex computer models we have. What is your adjusting the model really doing? Hard to say. Oops. And regardless, their interpretations, they're not necessarily the truth. I mean, you can see this real quick. Take a set of gridded topographic data from a topographic map, run it through a bunch of contouring programs, and depending on which mathematical model you use for the contouring, you come up with different answers. The major points will be common to all of them, but where those contour lines fall will change, simply on the basis of the model you're using. You can compare it to actual topography and say, that's really screwed up. But we're talking about, isopacks or something like that are, 10,000 feet down. We don't know. We just, it's a model that's an interpretation and may not be right. As long as you look at an oil field map, when the first few wells go in, and the geology is pretty simple. After you've got a couple hundred wells in, some there are all these little faults and offsets and so forth. More data gives you better results. Okay, I once sat through a professor of petroleum engineering giving me the proof that exponential decline is true for oil and gas, and it works most of the time. You plot a production on a semi-log paper, and pretty quick you get a straight line. The initial assumption: isotropic homogeneous layer of infinite xy and constant z. And all of us are laughing. No such thing. If you make that assumption, you can mathematically prove it works. This is one of my favorite outcrops in southwest Denver. It's a roll front uranium deposit into the Dakota sandstone, the fossil oil reservoir. Ilmenite is a molybdenum oxide that's blue, and so it's easy to outline. And in 2 dimensions, this is what fluid flowing through a beach sand looks like in terms of a geochemical front. Not a mathematically or geometrically easy shape to deal. Just heard about this from a colleague. There was a book published this spring on hydraulic fracturing. 2 authors. They quote a lot of other people's work. In one case, they got 2.5 chapters out of a paper introduced with a sentence saying, we took these from this other source. Other chapters are essentially published material that is no attribution given whatsoever. Clear plagiarism. Book was published by a fairly well-known scientific publisher. Anybody want to use this sort of book as their teaching? I love many. One of the best books I ever bought was the something Earth, Kristen Cloud's book, Adventures in Earth History, where he's got 86 different papers on all sorts of, the development of concepts in geology. That Freeman published back in 70 for $8, which was steep then, but still not all that bad. A tremendous source book, but everybody's credited for where those papers came from. And other societies have done compilations of one sort or another. That's not a problem because they tell you where the stuff came from. Pete Rose, whom many of you may know, has this list of his principles for deciding whether or not you need to cite the source. Did you rely on it? Is it reasonably recent? Because, and we'll get to this, that something becomes so well recognized that citing sort of becomes gratuitous. I still love quoting De Re Metallica and Hoover Principles of Mining 1909. The language is just so good. So, is it a recognized expert? Any harm done by doing it? Other than you're a student trying to pad the references section so your professor thinks it does a lot of work. But, you have to look up the reference anyway. Any harm done? Acknowledging the source? Probably not, but maybe think about it. Then the question is, I actually, my own brain came up with an idea that turns out that Fred over here did 5 years ago and published. Well, I didn't know about Fred's work. I published as my own original work, which in fact it is, but somebody says, gee, you didn't cite Fred. Well, whether you should have known about Fred is kind of a different issue, but again, the kind of thing that a student or any of us might find ourselves in. Okay, best practices and standards. Again, this is something that's coming up a lot in industry. Problem is that they're not correct all of the time. And techniques and practices evolve. For example, our ability to detect, minimum detection limit for various elements and compounds continually falls. And so rules keep changing down to the detection limit. Is that really a problem? I told everything. Gets into a legal tar pit if you're doing something that says, you've got a lawyer on the other side who says, this is a standard, you didn't follow it, you must be incompetent. And you have to explain to the lawyer why that's not true. So some classic examples of, you don't use fire assays for plaster samples. One of the best references on plaster sampling is a book by a guy named John Wells on plaster examination. It's a DLM technical bulletin that's been updated, but problem with fire assays is they report total gold content, and you don't get it with, you don't have the potential of recovering total gold content with gravity concentration techniques. You don't get total gold content recovery for anything, but for other mines you have to deduct your mining and processing. So anyway, high grade samples. When I worked for the SEC, that's what I did. High grading? Well, I didn't have a big time or monetary budget to go out and do a bunch of sampling, so I got, go out with a promoter and say, show me your best stuff. And I'd sample that. I graded. When it came back zip, we knew what the rest of the stuff was worth. So that, there are times, an initial examination of a prospect or something, you may want to do high grade. Because if the high grade isn't there, the low grade sure isn't going to be. So normally, is it a good idea? No. Are there times when it could be? Yes. And the improper application to differing conditions. Example. Denver has this problem with bentonite swelling soils in the Cretaceous shales. And so this is the standard procedure that the soil foundation testing people do, is normally the most parts of the Denver area, the rocks are essentially horizontal, so you go out and drill a bunch of vertical wells and find out, is there any swelling soil? And tell people about the results. Wonderful. Until you get to up by that hogback that we all love to go take field trips to, where everything is steeply dipping, if not necessarily vertical. And there, the standard procedure of drilling some holes the probability of hitting one of these bentonite beds is like 1 or 2%. It didn't work, and a lot of people have some severe damage to homes, to roads, to schools, because they used a standard technique that was not applicable to the area that they were doing. Okay, summary. Honesty is difficult, but we need to really think about pursuing it. Not enough to avoid conscious deception, the subtle ones. Those are the ones that are hard to think of. This is perhaps where reviewers can be of particular assistance. Describe what we don't know as what we know, or what didn't work as much as what did. Now I'm going to go in. My original assignment was talk about complex of interest. And then the most common issue that we perhaps face collectively. And you can go to aibg.org/about/ethics.html, and I have a topical index to all the columns I've written there. The 147 is about that come out. 91 topical entries on conflicts of interest along with something else, and so you're perfectly free to go in there. And actually, those columns, a little bit of searching through, the professional geologist is available online, except for the current issue, unless you're a member. And for a nominal fee, you can buy a CD that has everything on it. Anyway, the usual resolution for conflicts of interest is disclosure. And then people decide whether or not it's enough of a problem to do something. The failure to disclose is where you get into problems. Somebody starts screaming and yelling, well, there's this sort of inside deal that nobody told anybody about. And there are a limited number of cases, auditing being one of the primary examples, where conflicts of interest may not exist. I audit the reserve and resource estimates for Stillwater mining every year, and I can't hold any financial interest in Stillwater mining. I enjoy working with them. It's a great deposit. It's lots of fun, but I've got to be independent if I'm going to say this is good. Okay. One of the other things that happens in conflicts of interest is this failure to respect others' positions. And they have what I call these debate-stopping conflict extremism. Special interest groups versus public interest groups. The difference is, special interest groups are those groups that disagree with my position, whereas public interest groups are the ones that with whom position I agree. But you label the other guy as special interest, they're evil. Public interests are good. Showstopper. Academia versus the real world, we've all heard that one. I work for the natural resources industry, therefore I am by definition anti-environmental. We see it a lot. Isn't necessarily true. The research was funded by private industry and therefore must be biased. This is, I gather, really starting to come up as federal grant money is going down. More and more universities are having to look to private funding. The point with these is I think that they're disrespectful and immoral. Just because somebody disagrees with me doesn't mean that I'm bad or that they're bad. It's just that we have come to different conclusions because we rank goods, morally desirable things different. Again, the whole thing like public health, safety, and welfare versus privacy and 9/11 balance. Where is the appropriate level? We're debating along with it. Okay.